Hi, how are you? I'm fine, thanks to God. Now, today we will try to see the data structure in the algorithm course, the first chapter, what is data structure in the algorithm. So, as an outline, we will try to discuss about the concepts of data structure definition, arrays, stack, queue, linked list, binary tree, binary search tree, graph, hashing, algorithm analysis concepts, linear and binary search, storing data element values to an array or a stack or linked list. This data structure. What is data structure? This is basically a technique of organizing and storing of different types of data items in a computer memory. Different types of data items in a computer memory. So it is considered as not only the storing the data element, but also what? The maintaining of the logical relationship between the individual data elements. Program consists two things. The first one is the data item. Then the next one is the sequence of steps to solve that problem. So then sequence of steps to solve the problem. The steps to solve the problem. Good. Then this is what we call a program. Then the next one is how the Y or the wave data organizing in a computer memory is said to be data structure, and the sequence of computational steps to solve a given problem is called algorithm. So we have two things. The first one, the data structured and stored in a computer memory, what we call data, and the second one is the sequence of computational steps, the sequences of computational steps to solve a given problem, what we call, this is the sequence of given problem, sequence of steps to solve a given problem called in combination program, and this step is said to be algorithm, is called algorithm. Therefore a program is nothing but the data structure plus the algorithm is called a program. The data structure plus the algorithm is called a program. Then the next one is given a given problem. The first step is solve or try to solve the problem by obtaining one or its own abstract view or its own abstract view. Just this is called model building or which is called abstraction of the problem domain. Abstraction. What is the model? The model is defined as what? An abstract view of a given problem. An abstract view of a given problem. This is what we call it model. And also what? The model is the properties of a given problem. Model is what? The properties of the problem. Good. This is what we call the model. Properties of a given problem may include the data which are affected and what the problem, properties of a model or properties of the problem, properties of a problem may contain or it contains two things. The first one, the data which is affected, and the second one is what? The operation that are involved in the problem. The operation. So the data that we want to affect, that we want to affect. Then the second one, the operation is that we want to involve in the problem. That we want to involve in the problem. This is what we call the properties of a problem, or the properties of a problem. As you see, as in a real world scenario, there is a problem. And what? There is a model. There is a model. The relationship between these two, the problem and the model, is said to be abstract. What you call abstraction or abstract. Simply abstract. Just what you call algorithm, data structure, model, properties of a problem, and also what is programming. Just we cite this for data structure, program, and problem. What is algorithm? Simple. Define. Let us define what is an algorithm. Let us start by defining the word algorithm. So algorithm is a well-defined computational procedures, steps, or sequence of instructions that take some value as input or set values as input and produces or outperforms or displays or gives output. This is what we call algorithm. Algorithm is a well-defined computational procedures that take some value as input, some value as what? Input or set a value as input, and it produces some value as output. This is what you call it algorithm. Good. Then the next one is the equals input. There is an algorithm, method of computational steps, sequence of instructions, what you call algorithm. Then it displays output. Algorithm. Then there is an input. This is what we call algorithm. Then data structure model are static part of a real world. In our today's activity, real world scenario, they are unchanging while the world is changing. Data structure is unchanging, but the world is changing. In order to model the dynamic part of real world, we need work with algorithms. Why? Because algorithms are dynamic part of a program's world model that performs data structure from one state to another state, that transfers one state to another state. This is what we call algorithm. Good. So algorithm can be taught as a set of instructions that specifies how to solve a particular problem. Again, next definition. Algorithm can be taught as what? Taught as a set of instructions that specifies how to solve a given problem. That specifies how to solve a given problem. How to solve a given problems. This is what we call algorithm, another definition of algorithm. And also how we define it? It is a well-defined computational procedure that takes some value as input and produces output, as I told you before. So, algorithm transfers data structure from one state to another state in two ways. The first one is the algorithm may change the value held by a data structure, and the second one is an algorithm may change the data structure as itself, or the data structure by itself. So the quality of the algorithm or the quality of the data structure related to its ability to successful model, or the model of a real world problem, what you call abstraction, is the characteristic of the real world. Similarly, the quality of the algorithm is related to its ability to successfully simulate the trend in real world problems. However, the art of the data structure and algorithm is determined by their ability to work together well. Because correct data structure leads to simple and efficient algorithm, and correct algorithms lead the accurate and efficient data structure that we wanted to design to solve that real world problem. Good. Algorithms can be also, it may be good or bad. What we say to the reason to say algorithm is bad and to say the algorithm is bad, it depends on different properties. Let us discuss each one by one. The first one, the fitness of the algorithm. The second one is the definiteness of the algorithm or absence of ambiguity of the algorithm. The next one is what you call the sequence of the algorithm, which means steps each must be unique, defined preceding and succeeding steps. The preceding or the previous and the continuous or the next step should be clear and unique. This is called sequence of the algorithm, one property. The next one, the correctness of the given algorithm or the designed algorithm. It must compete with correct answer for all possible legal inputs. As we defined, as you remember from the definition, it takes input and the algorithm processes, or the algorithm makes an operation and produces the output. So the algorithm should give accurate or correct result or output based on the given input for all possible legal inputs. For example, we want to design a simple calculator for all arithmetic operations A and B. Input take as input A and B, and the output, the operation may apply different arithmetic operations for addition, division, subtraction, and modulus, and finally for multiplication for all arithmetic operations for input A and B. It gives accurate result C. The accurate result C for all legal input value A and B. This is what you call correctness of the algorithm. Language independence, it must be or it must not be depend on any programming language, for any programming language. After you design the algorithm or sequence of steps to solve a given problem, you can use any programming language to solve or to change the designed model to software or application. So in order to design, develop the application, a real world application, the algorithm should be independent, not depend on any programming language. It should be independent. For example, You can use Java, you can use C++, you can use C Sharp, or you can use other J Sharp and the like programming languages to develop the application, design mobile application. So it should be language independence. Then the next one is completeness. It must solve the problem completely, not partially. The design algorithm should solve a problem completely, not partially, not with remaining, not with remainder. Have you got me? I think. So it should be completeness. Then the next one is effectiveness, efficiency, generality, input, output, feasibility. These are some properties of an algorithm that we want to decide the designed algorithm is good or bad. The designed algorithm is good or bad. Good or bad. In order to decide the algorithm is good and the algorithm is bad, the above listed properties should be clearly stated. Good. So what or why data structure and algorithms are important? What's the importance of data structure and algorithm? Well, because we are concerning or we are dealing about data, we are dealing about the procedures or the sequence of steps to manipulate the data. So the data structure are very important. So if we say that are important to design a model or to solve a problem, what are the importance of this data structure algorithm? The first one is data structure algorithm have two of the most very crucial or very important aspects or resources in computing environment. The two are data structure and the algorithm are the two important aspects or concepts in computer science and related computing disciplines. What are that? Data structures allow us to organize and store the data, while the algorithm allows to process that data. Data structure organize and store the data. Sorry. The two most common important things in computing environment are data structure and algorithm. The data structure stores the data, organizes and stores the data, while the algorithm what? Allows to process the data and produce meaningful output. Data structure and what we call organize the data and what we call and store the data. Whereas the algorithm what it do or what it allows us, it allows us process and produces a meaningful output. This is the two crucial concept or areas in computing disciplines. So the next one is what is abstract data type? What is abstract data type? What is abstract data type? Okay, what is abstract data type? Starting by defining it. Abstract data type is an abstraction of data structure which provides only the interface to which the data structure must follow. Good. Then this is what abstract data type mean. The interface does not give the interface the interface doesn't give any specific detail how to implement, how to define, how to what we call yeah, we can say how to implement the problem. Just it only shows the high level logical view of the problem only. Logical view of the problems only. So abstract data types are not telling or does not tell any specific detailed implementation of the problem. So it consists of an abstract data structure and operation. What are that operations? It can be stored an abstract data type, and what operation can be done by the abstract data type. By the abstract data type. Those are what is stored and what operations are applied or done by the operation. This is what we call or what abstract data type, data structure and operation is. What abstract data structure is. Then the next one is what real world example that reflects or shows the abstract data type. Let's example, if you are going to model an employees organization, employees of an organization, just the entity or abstract data type entity, the entity or abstract data type stores employees with their relevant attributes, and discarding the remaining irrelevant ones or irrelevant attributes. The abstract data type supports what? Hiring, firing, retrieving, and operations, similar or other operations. But they didn't explain how hiring, firing, and retrieving of that employee is implemented using programming perspective. They didn't tell what or how they are implemented. Just only model or designing an interface. What operations can be performed? What operations? For example, here for employee example, hiring operation. The second one, firing operation and retrieving. These operations are designed in our entity, but they didn't tell the entity. The entity did not telling about how to implement that. Just only they show the interface of the highlight logical view of the problem. The logical view of the problem. Another example for mobile phones, smartphones. Another example for smartphones. Let an individual tries to design a mobile application. This is the mobile. This is you can take or count it as your smart mobile. Smartphone. This smartphone allows us calling, texting, some text message, capture photo or video. But they didn't tell us the entity did not explain how we implemented this. How we implement this operation. They did not tell how to do or implement this operation. But in real world programming or a real world implementation, it defines the method. For example, call. Family, public but in a real world. For call, public void calling some value, for example, and phone number as an argument. Let's simple example, something blah 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 blah. This is implementing, but the editor did not tell us how to implement the operation using this in programming perspective. Implementation view looks like this one, but the editor did not tell us about this. How we take the data, what the data organization, what operations are performed. But they only show us the physical or the abstract view or the logical view of the operation. For example, it requires to implement this one or to manipulate this one. The mobile phone requires 4 GB RAM, 2.3 processor unit, gigahertz processor unit, and the like 5.5 inch display screen, 5.5 inch display screen, and the like. This is the abstract view, but the implementation detail looks like this one. So as a definition, it tells us what entity are entities that are definitions of data and operations, but they did not show or have implementation detail. Like what? Interface, unimplemented method, in Java. Abstract data types only contains what? The data and the operation. This is operations: calling, texting, messages, taking photo, video. This operation should be handled by done by the mobile application, but the smart mobile. But they didn't tell us anything how to implement this. This is what you call abstract data type. What are the categories or classifications of data structure? What are the classifications of data structure? We're telling about as a whole the data, but there are different types of data in our real-world scenario, in our real-world activities or scenarios. So the first one is the primitive data structure in the non-primitive data structure. So data structure can be divided as the first one elongated and here primitive data structure, and the second one is non-primitive data structure. So what is primitive data structure? The first one is the basic or the fundamental data structure in real-world scenarios. For example, as a fundamental data structure, let as an example, integer numbers, floating numbers. Next one, characters, pointers. What the next one? Constants, string and constants. Actually, string constants. Yeah, string constants. These are primitive data types. But the next one is the non-primitive data types. What is this non-primitive data types? Are sophisticated derived data types from the primitive data types. Before that, non-primitive data type also divided into two. It may contain in or divide into three first. The first one is the array type. The second one is the list type of data structure. And the third one is what you call the files. As you call file. But we try to more split the list. List data type also, data structure also divided into two: linear data structure and nonlinear data structure. Nonlinear data structure and linear data structure. And also the linear data structure may contain come to here. Linear data structure also contains linked list, stack and queues. Linked list, stack and queue. These are the three linear data structures. Linear, non-primitive data structures. When it comes to nonlinear, this one, non-primitive nonlinear data structure. The first one is the tree, and the second one is what? Graph. Actually, this is the detail of the data structure or data placed or stored in a computer memory, either with the list one. It may be integer, floating point, character, pointer, or string constant. If it is not here, your data may categorize as non-primitive. If it is non-primitive, it may also array type, list type, or file type. If it is list type, it also linear data structure type or non-linear data structure type. If it is linear data structure type, it may linked list, stack, or queue. Or if it is nonlinear, non-primitive data structure type, your data may tree or graph. This is your data organization in computer, or any data organization in computer is categorized or included or counted as this one, either of this one. No, without this, your data is organized, or your data is organized by one of the listed data organization types or classes. It may be graph, linked list, stack, queue, integer, float, character, pointer, or string constant. One of this list is organized or counted or categorized your data in computer, in any computer memory. This is what you call data structure classification. So the first one, the array type. We are discussing about. This one is non-primitive data type. You are familiar in C++ programming and also in Java or other basic programming course. Your basic programming courses in Java, C++, and the like other courses, C# and also primitive data types. You are familiar. So, and I think you are also familiar in what is array in your fundamental programming course. So, what is an array? What is array? Simply define it. So, to define array is a linear data structure. Yes. Array is a continuous memory location. Yes. Array is access elements random. In array, elements are accessed randomly, and arrays are homogeneous element or having each elements of an array have homogeneous data type or homogeneous elements. Integer, if the array is integer, all elements of the array are integer, similar elements. So what's the application areas of array? Simply the highlight of array. The application areas of arrays are storing information in a linear fashion, suitable for application that requires frequent search, where apply arrays in such application areas. So arrays can be divided into two, or we can take arrays into what? The first dimensional single dimensional array 1D, and the second one is multi-dimensional array 2D. Arrays are homogeneous data element collection. Simply, arrays are collections of homogeneous elements. Simple. This is the definition. The next one, arrays may be one-dimensional or two-dimensional or single-dimensional array. 1D array elements are stored in one after the other. And also like this one, it is row-wise and stored in this one. For example, val1, val2, val3, val4 in this way. And this is the element or value at what? Index 0. At index 0, or the first index. And also this is also a value at what? Last index, or and -1, that means, or size -1, array size -1 index 2, array size -1, first index 0 index, or first index element value. This element value, this is the index 0 and -1 and -1. This is what about arrays. And in single dimensional array, the array element is accessed using the subscripts, and in single dimensional array, the subscript is only one index. At each cell, they are one index because they are single dimensional arrays. Then the next one is the declarations and initializations of arrays. To declare arrays, we first type or set the types of the array, like int and the array name, and the size of the array, then semicolon. This is array declaration. Example int and age of a group members of students, or ID number of a group of students, ID num, size 5, or ID name another, and in another explanation, or another way, and ID num equals to under curly brace 11, 25, 30, 31, 45, 55, semicolon. 1, 2, 3, 4, 5 elements. This means this one. This is array declaration and initialization. When it comes to multidimensional array or 2D, the definition is the same, but we add additional nested element value. 2D can be related for table or matrix manipulation, or having row and column problems. And elements are stored one after the other, like in one-dimensional array, but a row inside another column, or the first row having different n numbers of columns. two subscript numbers or indexes we use to access the array elements in two-dimensional arrays, and the dimension depends upon the number of subscripts that we used. The initialization and declaration initializations are and like that of single dimensional array, array name, then the row counter, then the column counter. You should declare here value. For example, 3 by 2, then semicolon, which is looks like this one is equals to 3 rows with 2 columns. 1, 2. Looks like this one. No. Looks like 3 rows like this one. The first one, this cell is 0, 0. Array name, location 0, 0. This is the index of this one. This is the index of 0, 1. The index of this cell, and this is the row is incremented to 1, and the column is 0, set to 0. And this is the row constant 1, and the column is incremented to 1, and this is the row is incremented to, and the column is set back to 0, and this is the row is the same too, and the column is incremented to 1 to 1. This is what looks like multidimensional array implementation and declaration. This is what two-dimensional or 2D array looks like. To access each element in 2D array, we use these subscript numbers, 2 subscript numbers. The first one is the row indicator, and the second one is the second index is column indicator. Good. So this is a row, this is a column, this is a row, this is column, this is row, this is column, this is row, this is column, this is row, this is column. Good. So in order to use these 2 indexes, we apply 2 for loops. The first for loop is for row, for int I is equals to 0, because the index in array starts from 0. I less than array length, array name dot length, semicolon I plus. Inside this we also say another for loop for column, for int j is equals to 0, j less than number of column, the same. I think this is better to say. Rather signed array length, it is better to say I less than 3. Semicolon I plus here I less than 2, semicolon j plus. Then inside here the array name, to set values, the array name we can add the values for the first for loop and close here for the second for loop. We use 2 for loops. This one is for row, this one is for column. This is compares with number of rows. This is the column, the nested one, the inner for loop compares with the column, number of columns. This is how manipulate the array. To this in array. The next one, how we implement it. To implement this array, 2D arrays, just back to the code editor. Okay, come to the implementation one. We use Eclipse IDE to implement single dimensional array as well. you can use any programming language, but now I use Java programming language via Eclipse IDE. So open your Eclipse IDE and create a class which is called single dimensional array. Whatever you can give any name. Open a class single dim array, single dimensional array, and then inside the class you can create main method, public static void main string args string rg character variable, then open your main method calibrates body and create or declare array of character variables, and array symbol, then the array name, like what the array name, single array, it is enough, equal to new int of size how much, 5 element, having 5 element, then int. Then the next one, create another constant variable, another literal variable, and count to assign the value of each index new value. Count is equals to initially 1, and then we should create for loop to iteratively or continuously store this collection element value. So using the for loop for int I is equals to 0, starting from 0 index to what single or I less than single array dot length integer value, semicolon I plus, then inside the for loop you can add list of values for each index. So array name of I equal to what? Just count. At the first index we add the count value, then here count plus semicolon. After that it is better to display the values of each index. Therefore also we use for loop, and just j is equals to 0, j is equals to 0, j less than array length dot length semicolon j plus, then inside for loop body display the contents of the array. So system dot out dot print line j and run it. Just execute, right click, run as Java application, then what will be the output? 0 1 2 3 4. Sorry, don't say j, count. This is the element, j is the index. 6. Oh no. A of what? J, not A of, that means array name of J. This is array name of J, meaning the count, incremental count value from 1 up to the end, 1 2 3 4 5. This is the print line to make a space between here plus, yeah, run it again. 1 2 3 4 5 element values are displayed here. And also you can display the index for each, like here j plus concatenate, that means concatenate space. Here we can add the colon, and also here add the concatenate sign, then index value, right click, yeah, the at index 0 1, at index 1 2, at index 2 3, at index 3 4, at index 4 5. Print line, make it print line. Actually it is not, this is linear, arrays are linear data collection, but to see the difference between the i's and the j's, or the index and the value of that index, we can add here print line, yeah, at 0 index 1, at 1 index 2, at second index 3, at third index 4, at last index 5. Index starts from 0 and ends at array length -1. This is what this is for single dimensional array. What about for multi-dimensional array? We can simply add the column counter. Nothing we add without this. So what here we add is, this is for single dimensional array, and for multi-dimensional array, add here another column, this, and here add this one, and here just two, the first for loop for row counter, the second for loop for column counter. Here we add another for loop, inside the for loop, open brace, and here actually already for and t equal to what? T equal to 0, semicolon, t less than what? Array name dot what? Array name of I, comma t plus plus. What is this one? This is the array name, and what the problem here? Operator is undefined, the argument and it is equal 0 to less than single array of I. It is a single array of I, t plus plus. That means t equal to 0, start from 0 to less than size should be added here, 4. Size of the column should be specified, 5 by 4. So array, single array for the first one, or we can add a1 dot length or array1 dot length, the same. Then plus plus for the first for loop. For the second one also, and dot I of I dot length. We should add the column counter. We should add the column counter, and the next one j plus plus increment, also the column also increment, and also we should add I and t. The i's and t's values equals to count, and also for count plus plus. Then for the second one also we use another second nested for loop. Enter here to display the values. Actually we should close it finally. We should display the values. Int j is equal 0, j less than single array dot length, the same as that of the above one, j plus plus. For the second one also, yeah, this one is j array length of what, j, this should be what you call r. You can say r is an array, single array dot length r plus plus to display the content. Single array of what, the column is j, the row is j, and the column is r. Yeah, done. Then when we run it, actually it is better to remove this one. It is better to remove why? Because ij for now it is better to remove it and display as it is, and also remove this line and run it. We should have 5 times or 20 elements. Yeah, 1 1 3 3 4 4 5 5. No. Count should be incremented here. I think second one row at the end of this one. Try this one. No. Okay, count plus plus. What we need to do here is that count ij, the first for loop I, the second one is t is equals to count, then count plus plus. Okay, good. We should close 2 for loops here and reduce here the number of for loop. Yeah, 2 for loop, the first for loop, this one, and we should open another for loop here for the nested one. Yeah, this is a programming indentation error. Then and also back to here. Yeah, this is good, and also remove this one. Definitely this. I think another additional 1 2. Okay, 1 1 2, additional another for the class brace. Yeah, run it. I think it works better. Yeah, 1 from 1 up to 20, and we want to display one row with 5 row with 4 column. Okay, so say here system dot out dot print line, yeah, and save it, run it again, run as Java application, then it works well. Yeah, 1 up to 4, 5 up to 8, 9 up to 12, 30 up to 60, and 70 up to 20. 5 row by 4 columns. 5 row by 4 columns. 2-dimensional array implementation looks like this one, using 2 for loops. Good. This is how we implement array. So please like, share, subscribe for today's, and bye.